Hello everyone, my name is David and today I'm going to record this video. Let's get started. Usually watching a video on YouTube on a computer more powerful than anything humanity have built a few decades ago. This process and other wonderful machines you guarantee are built on very rare and precious material with names like thorium, nonium, and tantalum. Getting these rare materials from the ground in your device is ugly. The mining industry is responsible for air and water, and the destruction of entire landscapes. Dangerous chemicals like cyan, sulfuric acid, and chlorine are used to extract resources, harming bloody workers and locals. Rare resources also political tools when countries restrict access to them in a way. But what if we could replace mining industry on Earth with a clean process that can't harm anyone? Well, we can. All we need is just to look up. Asteroids are millions of trillions of tons of rock, metal, and ice. Leftover from a cloud began the planet 4.5 billion years ago. It can be small as a meteor or protoplanets size of entire countries. Most of them are concerned in the asteroid belts and the Kuiper belts, while hundreds of thousands more do their own thing between planets. As space travel became more feasible, scientists and economists began looking resources around these asteroids, even related to small. Many contain trillions of worth in the terrestrials and precious metals like platinum, and even bigger asteroids like 16 Psyches could cover the world's metal needs for millions of years. The current market prices rare raw materials alone could be worth quadrillions of dollars, but, well, technically not. For example, there are more than 20 million tons of gold in the ocean's water, worth roughly 700 trillion US, but filtering the gold will be so expensive that you lose the money selling it. Right now, the asteroid mining has exactly this problem. It's too expensive to replace mining on Earth. Billions of dollars worth valuable resources, and it costs trillions to get them. What makes it so hard? The principle behind mining an asteroid is simple. Basic idea is to choose an asteroid, move it to a place when easy to process, and take it apart and turn into useful products. Unfortunately, all of this lies to a fundamental problem humans have yet to solve. Going to space is expensive. It costs thousands of dollars in rocket fuel, and for each kilogram it just reached low Earth orbit. Going further into deep space costs thousands more. We need cheaper space travel to make asteroid mining cheaper. One solution is to switch from conventional rocket to an electric spaceship. We already use electric rocket engines for many space probes for science mission. In principle, we only need to build bigger ones. Well, electrical engines are not powerful enough to fly to space. They only require a tiny amount of fuel to go very far. This means we don't need to spend a lot of money on fuel, only to transport fuel into space. This doesn't solve the whole cost problem, but it's easier to start our first mission. Now that we have an electric asteroid mining robot, we need to find the right asteroid and get it there. We successfully visited asteroids with space probes and even collected samples. Still, to make it easier and cheaper, our first target will be probably near-Earth asteroids that orbit well near Earth. After a few months of travel, our spaceship arrives at the asteroid, weirdly formed with littered with small packed. It hasn't changed much of millions of years. The first thing that needs to be done is secure the asteroid and stop it from spinning. There are multiple ways to do this, by vaporizing material with lasers or stopping rotation with thrusters. Once we have a stable asteroid, we wait. Orbital mechanism is possible, but if you push something at the right direction at the right moment, you can move little big things with very little force. So we wait at the exactly right moment. Now ship fires its thrusters and nudges the asteroid to a trajectory where it takes near our moon. The moon is useful because we can borrow its gravitational pull to the Earth, which saves more fuel. Again, the trip takes months, but the time since our whip has launched it has not been wasted. The first space mining progress equipment has been installed in orbit and now carefully moving towards. The processor works very different on the Earth. Giant mirrors focus sunlight and heating up asteroid rocks to boil the gases, grind to break up the dry rocks and gravel and dust, and separate dense from elements. We only travel 0.1% from the asteroid mass in the asteroid. We still get this several times more than you get from the same amount of core on the ground. But what now? How do we get our precious metals safe back to ground? There are few ways, like loading to reusable rocket that turn from Earth to space. But if process has a contain 3D printer, we can print a faster and cheaper delivery system that shield capsules filled with gas bubbles that can be dropped into the oceans and where ships tow them away. This could be a starting point of humanity's really first steps towards colonizing the solar systems. Our infrastructures and experience grow, and our missions get more and more sophisticated. Parts and field roofs and don't have to launch from Earth at all. First mining operation may take the second one easier. While space industry goes, the precious material becomes cheaper and eventually we can stop mining on Earth. The idea of toxic mining down here might become a weird and astronomic, like having an open fire in your living room. Landscapes ravaged by pollution will heal, while technology we're used to that's cheaper and less toxic to make. None of this is science fiction. We don't need fancy materials or new physics or to make asteroid mining happen. We just start building this future today. All we need is an internal push. That's the end of the video. Thank you for listening. Goodbye.